Hello everyone. Today we are here to present the presentation for Sprint 3. Our team name is EcoScan and we are trying to develop and plan a leaf disease detection system. Next slide. So today we'll be covering the points on the board: problem statement, problem description, personas, market analysis, project timeline, MVP, project backlog, test cases, user stories, and acceptance criteria. And what is to be done, the retrospective and the sprint 4 target. Our team members include me, myself, Omkar, Shriya, Ritika, Lokesh, Niyati, Uma, and Mukesh. So from the retrospective from last sprint, we got some feedbacks from the professor and we have tried to add the acceptance criteria and user story in the same slides, add project description as part of the template, made changes in test cases and made them better related to the user stories, added team velocity chart, and included the demo in this presentation. So moving on to project description. So the target of this project for us is going to be completing the MVP, and the MVP includes the aiming to optimize crop health monitoring, minimizing and helping farmers to easily use and detect plant diseases, and also try to evaluate how they could make changes to benefit the crops. Next. We know that the increase in HIV seeds and all the other diseases affecting the food industry, and we are just trying to uh, make sure that the plants have no diseases and make a healthy plant and crop yield. Next. In the team agreement, we cover the points such as how many times do we meet in this project, like weekly, and what are the communication ways, and what all are the parts that we are going to divide amongst ourselves. The project includes 3 personas. The first persona is Eva, the farmer. She's a farmer and she's trying to make changes to her existing crop yield and understand how she could improve the yield. Next is Raj, the techie guy who is working on coding contests, and he's trying to make changes to the existing softwares that are available in the market. And the third one is the legal advisory for, we can say that she's an intermediate between the guys and the coding. Next. The MVP includes we able to select a particular image in certain formats like JPG, PNG, and detect what kind of diseases that the plants have, and also to predict and recommend what the user should do in order to improve the yield. The tools that we have used, the technologies that we have used, and the languages that we have used are Python, NumPy, OpenCV, Keras, CSS, Jira, TensorFlow, HTML, Visual Studios, and Git. We have used, next slide. We have used them like for front end, we have used HTML, CSS, and Figma for design. For backend, we have used Keras, Python, NumPy, TensorFlow, and for database, we have used Django and all the connections. And for management, we are using Jira, WhatsApp, Git, and Microsoft Teams.
Okay, so talking about the algorithm which we have used, so you can go to the next slide, please. So the data set which we are using is the plant village data set, which consists of 8,000 RGB images, from which we are using 70% of those images for training, 30% for them for testing, and the plant types which we have chosen are, there are 14 types. You can see them in the next slide. The number of classes are 38. So this is the data set, how our data set is going to be looking like. Next slide, please. So as I mentioned about the class data set, so these are the different classes which we are going to be looking in the our project. So we have just tried to just give the importance to one of the basis on the basis of the number of images and the plant type. So you can see the orange has the maximum importance in the data set, and the model which we have been trained on is VIT model, that is the vision transform model. Next slide, please. So before going to the model, we can just understand like what we have done for our data sets. So we have performed some standardization. As you know that we are dealing with the images, so it's better to have all the images in the same pixel format. So you will have a uniformity across the data set. And for the transformation, we have just scaled the images to the grayscaling. So it will give us the efficiency for the machine learning algorithms. Next slide, please. So like I mentioned about the VIP model, so this is the model architecture which we are going to be using at. So our model consists of the basically 6 layers. First layer is the vision transform layer. Then we have used the flattened layer, two batch normalization layer, and two dense layer. So this is the model which we have used, and the classifier which we have been using is the softmax. And you can see over here the what are the total parameters which we have been working on, the trainable and the non-trainable parameters for this particular project which we are doing. Uh, so based on the data set and all the model descriptions and the model training, so the training accuracy which we found out is to be of 98.2%, which is the good accuracy as we feel. And the validation accuracy is 96.8%. So we have just tried to plot it as per the diagrams, as you can see over here, in which the training accuracy can be seen in the blue line and the testing accuracy is for the orange line. Similarly, we have done for the model losses as well. So here you can see the training loss and the testing loss for our model based on the number of epochs on which we have tested our model. So this is the app for machine learning.
Hello everyone, I will be explaining about the diagrams, whatever we have. So I am Omkar, I will be explaining about the diagrams. So first one will be a conceptual diagram. Conceptual diagram shows us how the user flow is actually going, like what is our concept and how what are the things are present will be the part of our website or the project. So basically user will log into website, he will land on the home page from here where he has 4 options. He can go for about us page where he can understand about what is the project and what's the motivation and what are the things we have included. Then next will be area details, which will conclude about the things which are the farmer wants to know about the particular area. What is the soil and what are the types of things available in that particular area. Next will be weather details. Weather details will have what are the things like what is the weather scenario at that particular area, current weather. We are trying to implement what is the current weather at that particular area so that it will help farmer to take a yield accordingly and make precautions accordingly. And the final page will be our MVP, which is our disease detection page, where the farmer will upload the image and he will get the analysis. Next is our sequence diagram. Sequence diagram shows us how a user will interact with the complete project. So user will come on the website. First, he will create his login ID and credentials. Then it will go to a storage. We can get we'll get the authentication if it is successful or failure. Then later he uploads the photo of a crop, whatever he wants to test, whether it's and get the analysis. This photo moves to a storage, then we send the URL of that particular image to our ML model. It gives us the analysis back. We stores the analysis with the photo ID and URL in our database, and we send the uh, basic our analysis to the user on the website. So this is our sequence diagram. Next is our class diagram where we have created basically 6 classes where there are users, farmers, crops, diseases, images, as well as analysis. So we have user since there are users are separate because users can be a farmer as well as from our admin who can as well as another people who wants to visit the website. They are not particularly completely a farmer, so we have user, farmer, and they can upload the crop. Under crops we have crop ID, name and description, as well as for images, we are taking image, crop ID, farmers ID, and disease to segregate all the crops, all the images added by every farmer, so he can track the history. When we come to entity relationship diagram, we have here majorly 6 entities, and we are showing how every entity is having a relationship with all other entities. So basically, one user can be either like log in as a farmer. If that farmer can upload multiple images which are uh, like basically multiple images can be associated with crop. Each image will have different kind of analysis, depends on what are the diseases it had and what are the preventions we have to take from that basis. And for the crops, each crop we have this stored in our database. If that matches with our database, the image which was uploaded by the farmer will correct it, like connect with the database what we have, and we give the analysis ahead. And next will be the state diagram. This is how our states will change. Like when user logins, it will start with it will check, it will go on the website, it will upload the image. Our website will check if the image is in a correct format or not. If the correct image is in a correct format, it will move ahead and match with the crops which we have in our database, and on the basis of that it will give a analysis. If the image is of a wrong type and it will like it has a wrong file type, it will show as a rejected crop image, and it will uh, inform the a farmer that you have to upload a new and valid image format, and later we can log out. Further will be explained by Niyati.
Yeah, so I'll be explaining what we did in the sprint too. So we designed the front end of the MVP. We also had the image upload function for uploading the plant image for detection, weather forecast page with the select area and the output showing what the weather is in that area, and also the area page with details about that area's soil, crops, etc. And we also did diagrams such as architecture, conceptual, and sequence diagrams. We also had the home page and about us page. We did the retrospective user stories, acceptance criterias, and application test cases and demo. Next. So the product backlog. Next slide. So in the product backlog, we have, which means the end product that we need, the tasks we need to do for that. So the database part we need to do, the CSS formatting, the login page authentication, the backend connection, API connection, the weather information with the web page, the weather information with the API, and the retrieval efficiency from database. Model accuracy, we need to improve that, and deliverable 3 and the wiki page updates. Next, Ritika.
So I'll be taking over from here. So here we have all the user stories or tasks that are to be done for the overall project. So here we see that we have 6 story points here, which have been already done for the sprint 2. So we have 5 in plan in the disease detection system, where we have like the user uploads a image of plant leaf and detects the disease. He also would want to receive the information about the disease that has been happened to the plant. He also wants to know about the prescriptions or suggested supplements which can help in curing or preventing the diseases. And the user would also want to see the stages of the detected diseases for better understanding. So these five story points have been completed in the sprint 3, and they have been placed under the disease detection. And coming to the 6th one, that is the user would want to verify if the image being uploaded is in the right format or no. So that is also done and has been placed under user interface. And in user interface, we also have sending prompt to user if the image is not in the correct format, and we have also completed this story point. Next one. So here we see that we have another one story, which is knowing if the crop is available in our website's database or no. Even that is done and has been placed in the database detail of our website. And from the IDs 9 to 15, we still are working on them, and those will be our product backlog and will be completed in the sprint 4. The next one will be taken up by Mukesh.
Hello everyone, this is Mukesh Sudala and I'm here to explain about the acceptance criteria of our project. Here we can see few case scenarios with its criteria and the features in our project. So here is one of the case scenarios where the user wants to upload a leaf image. When he wants to upload the leaf image, our EcoScan website will be able to store the image for processing and will be able to detect the disease, and this comes under the disease detection feature. And we have also another case scenario where the user wants to know the detailed information about the plant disease. Given where the user he uploads the image and should be able to get the detailed information about the detected disease, and our website should be able to store the information and pass it to the user. This also comes under the disease detection feature. And another case scenario where a user wants to view prescriptions and supplements of the plant, where he wants to view the supplements suggested for the disease being detected. Our EcoScan website will store the information and give the certain information required for the user, and this also comes under the disease detection. Next slide, please. Here is another scenario where a user wants to know preventive measures required for the plant disease detection. Here, given that I'm a user, he wants to know the steps to be taken care and to cure and prevent the detected disease. Here are the criteria of the project, and this part is our EcoScan website should be able to provide diagnosis for the disease. And another case scenario where the user wants to look at the disease and the stages of the disease being detected. In these all stages, our EcoScan website will be able to provide the diagnosis for the disease in all the stages. This is still in progress. This also comes under disease detection. And another case scenario where a user wants to check weather condition. If a user uploads an image and want to know about the weather condition, our EcoScan website will check the image and it's for my user. And this will also come under the weather condition. Next slide, please, Omkar. Yes. So here's some other scenario where a user wants to know if the image is uploaded correct or not. When the user uploads a correct image, our website should be able to tell whether the image is uploaded in a correct format or not. So our website will check the image and its format, and this feature comes in the user interface feature. And here is another scenario where a user wants to check crop type existence or not. Here the user wants to know if the crop has selected is available in the data set. So when the user inputs this, our website will check if the particular crop is present in the data set or not, and then give the required output for that. This comes under the image checking database feature. And another scenario where a user wants to know about the growth conditions for his area. When a user wants to know about his growth conditions, our EcoScan website will be able to provide required information on crop suitability, and this comes under the agriculture information feature. Next slide, please. Another scenario where a user wants latest news related to agriculture. When a user needs some news related to the plant or related to the area in his area, our website will be able to provide the latest news that are related to the agriculture and farming. And another case scenario where a user wants to receive notification about his plants. So when a user wants to be notified about all the reports and all the images of the plants, so our website will send timely notification whenever needed for that user. This comes under the notification feature. And when a user wants to explore and learn about farming, our EcoScan website will be able to provide all the information needed for the plants and about its plants. So here, this comes under the agriculture information feature. Next slide, please, Omkar. Yes. Here is a scenario where a user wants to create an account and log in using his details. When a user wants to log in through his details, our website will be able to generate the login credentials and will be able to get him logged in the home page. And when a user wants to log into the website and to store some information, if he wants to, our website will be able to log in with his login credentials and the store the information, whatever needed for him. This comes under the login feature in our project. And when a user wants to log out and secure information after all the process, so our EcoScan website will be able to log out from that and by securing all the information needed for the user. And this comes under the logout feature. Yes, our next slides will be explained by the teammates.
Okay, so coming to sprint 3 backlog, can you go to the next slide? So basically, sprint 3 backlog are the user stories that we were not able to complete in sprint 3 and will be completing in a last sprint, that is sprint 4. So we have 7 user stories in total that have to be completed. So they're all related to weather conditions and checking the type of soil and seeing if the crops are suitable for the growth conditions in the particular farmer's area where he wants to grow, and also regarding receiving the notifications and updates about the replant uploaded, and also learning new farming technologies and practices. So these 7 user stories will be done in the sprint 4. The next one will be taken up by Aishwarya.
Hello everyone, I'm Uma Maheshwari and here I will explain about the test cases for our project EcoScan. So here we have 9 different functionalities to be tested. And for each functionality, we have different test case scenarios. We also do regression testing just to make sure that the implemented functionality doesn't break the existing functionalities. So coming to our first functionality, which is image upload functionality. So when the user uploads a valid image, it should give the details about the display, prevention supplement stage, and details of the particular disease. And when the user uploads invalid image format, or when the image is not a plant leaf, then it should prompt an error message saying the same, so this functionality is completed successfully. And the second functionality is area report functionality. Here, when the user requests for a report of a specific area, or if the area is non-existent, then it should give the details and error message regarding the same. And the third functionality is soil type and plantation details. It is about the particular soil type and what plantation is good in that soil. It should give the information regarding that. So here we have 2 different test case scenarios. One is when the user asks for a specific area report, it should give the accurate information. And if the area is not available, that is the data on that particular area is not available, then it should inform the user regarding the same. Next slide, please. So here we have user interface and navigation. Here we have 2 different test case scenarios. When the user navigates the website without uploading an image, then it should be able to give the user the information of the website. And if the user attempts to access restricted areas, then it shouldn't allow the user, and it should ask for the login details before allowing it. We are still working on this functionality. Here, the another functionality is prevention supplements information. When the user views prevention supplements for a specific disease of the plant, then it should give the details about the prevention supplements. And if the prevention supplements for a specific disease is not available, then it should inform the user regarding the same. This functionality is also completed successfully. And another functionality is disease stage information. Here, when the user wants to check the stage of a detected disease, or if the plant is completely healthy, so it doesn't have any disease, then it should inform regarding the same. And if there is a disease, then it should display the correct information and the correct stage of the certain disease. This feature is also completed successfully. So when user asks for area report with historical data, it should give the report for the specific area. And if there is no historical report available for that data, that area, then it should inform regarding the same. Next slide, please. And here we have user profile and preferences. So this functionality should be able to allow user to update their profile information, our preferences to set the notification alerts, which we are still working on. And feedback and support. When the user submits feedback through the website, we should be able to receive that in order to make the future changes by going through the data. And when user accesses the support section for assistance, they should be able to contact or reach out to the people to ask for the support. Here we are still working on this functionality too. Next slide, please. So yeah, those are the test cases. And here are the stories completed by the end of the sprint 3. So we have 8 different user stories, and the total story points comes to 22. Here we have completed the user story when an user uploads an image of a plant leaf to detect the diseases and to receive the detailed information about the detected plant. They should be able to view the prescriptions and suggest supplements for the disease. Users should be able to receive the information regarding the various cures and preventive measures for the detected disease. They should be able to see the stages of the detected disease for better understanding. Users should be able to verify if the image is right, and it should allow it should prompt an error if the image is not in correct format. And they should also know if the crop is available in the database or not. So all these stories are completed by end of the sprint 3. Next slide, please.
Hello. Yes, so our team velocity comes to 22 story points that we have completed in this sprint. Team velocity is basically the ratio of number of days to the total number of story points. Next slide. As we can see that we had 25 story points in sprint 2, and we have about 22 we have 22 story points in sprint 3. We have completed targets for both the sprints. Next. Which gives us a completed ratio of 100%. That is the completed story points to the number of story points that were to be completed. As we can see in the burn down chart, we initially had a little too much work to cope up with and too many detailed story points. But as we went through the projects halfway through the sprint, we tend to make it an ideal scenario and then complete it throughout the sprint.
Hello everyone, I'm Lokeshwar. Now I'm going to continue this retrospective part. So retrospective part. So this is the whole idea board which we have performed joining a team, and we did a retrospective video thing too. And it is available as a link in wiki page, so you can find it over there. So we have many what went well and what can be improved. So from this we have kept like voting system, like everyone gonna vote them, and we are gonna take majority things and action item things. So these are the things went well. Coming to the next. Yeah, this is the recorded video screenshot we have uploaded in the GitHub link. So you can find it over there. So what went well? So coming to the what went well, drafting of the technical paper as per IEEE format. So we just follow every rules for the IEEE format and we prepared the technical paper. So we are happy with that. So next thing, achieving the desired results and learning with collaboration and updating the task on Jira. In this sprint, I think we are very good on updating tasks on Jira, like which we have a backlog in previous sprints. So now we are happy with this. So task allocation and effective communication. ML machine learning models with good accuracy and less losses. Coming to what can be improved. So updating the task on Git. So even in this sprint, we are lying with this task updates in Git. So we will make sure that we are going to do this in next sprint for sure. And team members joining the meeting strictly on time unless any emergency. So working on other features after completing the MVP to learn more. Work and personal time balancing. So we are going to improve this in upcoming sprint for sure. So action items. So I think we should mainly concentrate on these action items in upcoming sprint 4. So the first one is backend and database connectivity. And the second one, making sprint 4 agenda clear and adding better stories. So we are going to add a lot of stories and better stories for this project for sure. And last one, user authentication page. So right now we are working on that, and we'll make sure that it will be completed by the sprint 4 end. So that's it. Yeah. Thank you.
So basically, this is our code snippet. Like Basically this is just a part of a little bit part of a code where we are showing what we are doing for training and testing, how we are loading the images, and what's the batch size and everything, and what is the like how many images we are taking for how many classes. Further will be plan for the sprint 4. This is the plan for sprint 4. Our major plan for sprint 4 is creating a login, user login and an authentication system. And apart from that, database, we have to make sure all, like we have to make sure a few things we have to implement. Those are like showing plan details as well as weather information to the user. It's one of the part of our project. And apart from that, we have to also see make some CSS formattings. We have to connect database and improve the connections. Apart from that, we have to make API better API connections as well as retrieval of data. Like if whenever user adds the image, it should compare like to improve the accuracy. We have to make sure that it finds everything in database well. We have to improve the accuracy, and further is our project demo, which will be shown as video, as well as we'll have some screenshots here. So this is how our app looks like. This is our home page. This is our about us page. This is our area details where we are telling about what are the soils and what type of plants are suitable for this particular area if you choose this. Next is for our weather forecast page. Currently, we haven't created with the village data. This we have are just some garbage values. We are still working on weather forecasting page. And next is our technical paper. This is how our technical paper looks like. We'll also attach a link for the technical paper, which will be also uploaded on our wiki page. This is just a snippet of our technical papers. This is our wiki page link. And thank you everyone for creating this project and working rigorously for sprint 3. Thank you.
Thank you, everybody.
Thank you, Omkar. Thank you.
Thank you.
Thank you, everyone.